Alright, so today's lesson is a little bit different again because I am using the whiteboard for a lot of the lesson just to make it look a lot bigger than it would on the smartboard for the other classes. So if you are at home and you have your textbook with you and you're listening to this for the first time, go ahead and, if you have your book, go ahead and turn to page 223 in your textbook at section 4-5. That section right there on page 223 will be basically what I wrote on the whiteboard during class. There's a little section on the top of the page that says Cramer's rule. It has a C and an A and an F and all those sorts of things, and that's what I'm talking about for the first couple. Before we get into that, though, I want to go over one of the things that I didn't finish in yesterday's notes. So today we're finding the area of a triangle with determinants. Should not be Cramer's rule, should say determinants. So with determinants, we're also going to use Cramer's rule to solve systems of equations and then set up real-world systems of equations and solve them using Cramer's rule. So the first part that we should talk about is what we missed yesterday, which is talking about the area of a triangle with determinants. So the area of a triangle normally is 1/2 base times height. And so when we're talking about determinants, we're talking about using the vertices of the triangle that may make it difficult to figure out what's A, or what's height, what's base, etc. So on this one, for example, I have points. So I have 2, -3, 7, 4, -5, and 5. So if I come over here and I plot them here, it's 2, -3, 7, 4, -5, and 5. And if I draw a triangle connecting all those dots, it won't look great because I'm not an artist, but you can tell that it would probably be a little bit difficult to figure out exactly what the height of that is because we're not exactly on, all of the lines of the grid. So what we can do is we can use a determinant to figure out what that is. The area of a triangle has these vertices. If they're given to you in this order, go ahead and do them in this order. If you just get a graph that looks like this and you have these points, I would start over here and go around this way. Go in a clockwise direction for all of your points. It shouldn't matter which one you do, but that's what I would suggest. So what we can do is we can go through each of these, and I know 2 is going to be A, B, C, D, E, and F. And then I have this equation right here. Right now, though, I'm just going to focus on this part. You cannot distribute a scalar across a determinant because it doesn't work the same as matrices. That would be saying if I distributed that scalar, I would be moving all of my dots. I would be now at 1, 1.5, about right there. If I went the other way, I would be at 2, and then 7 divided by 2, so like 3.5. And notice how my triangle already looks kind of funky. So you can't distribute scalars across, so I just focus on this part first, and we'll just do that first. So all you do is you just plug in your numbers. So 2 and -3 are A and B, C and D are 7 and 4, E and F are -5 and 5, and then I just have 1s all along this column. So now if I go through my steps, 2, -3, 7, 4, -5, and 5. Draw my lines. Here I will get 8, here I will get 15, and here I will get 35, and that should give me 58. If I go the other direction, -20, well, actually I'm going to write it down here, -20 plus 10, plus -21, which is -41, -31, and then we just do the same equation. So 58 is my first one, minus -31 or plus 31 gets me 89. I found that, so now I can plug that back into here, find 1/2 of 89, and I will get 44.5. Now, when we're talking about area, you have to have something squared. I'm not told what I have, so I would say units something where it'll say centimeters, meters, inches, etc. And then you can figure it out from there for what you should plug in. Let's go on to the next part. That should help you with 17 and 49 on the homework. Obviously, I told you that this is why matrices matter, so why should you care? The guy in this slide, this is Gabriel Cramer, and he made a rule for a system of equations using determinants. So in physics, you might have some problems that have a lot of variables, and you have no idea what to plug in for those variables, and it's really hard to solve a system of maybe 10 equations. So we can use determinants. I'm not going to ask you guys to solve a system of 10 equations. I'm going to ask you to solve a system of 2 or 3, so don't worry about that. So this is what you can look at on the page in your book that I told you to turn to. At the very top is all of this information. So basically we're talking about a coefficient matrix or a coefficient determinant. So this is a capital C. As we're talking about that, all that means is if you notice, I have taken the coefficients of my x and y in my first equation, put it in the top row of my coefficient determinant, taken the f and g are the coefficients of my x and y in my second equation, and put it in the second row of my determinant. And that is my coefficient determinant. That is what is plugged in here and here. Then we have these things for x and y. So x and y, you notice for this one, I took m and n, so I took the constants here, and I put them, if I were to move everything over, take the equal sign out, take the plus sign out. I just moved these here and transferred them here. And then I took b and g and just plugged those in as well. So that's how you would find x, and then similarly that's how you find y. So a and f in x's place here, and then m and n as my constants. So now we can use this rule to evaluate some systems of equations. It does not matter usually the order that you do it in, because if you swap the numbers around, as long as you're keeping m and b in the same row and n and g in the same row, then it should be okay. You will, in one, you'll get a negative answer, but then your coefficient matrix will help that go back to what it should be. So the order doesn't matter on this one, as long as you keep the rows and columns where they should be. So what I like to do first is I like to write down what each of my variables are. So I know A is 5, B is negative 20, M is 8, F is 10, G is 25, and N is negative 2. So by doing that, now I can figure out what my coefficient matrix is first. So coefficient matrix, coefficient determinant, will be AB, so 5 and negative 20, FG, which is 10 and 25. And then from there, so I have 5 and negative 20, 10 and 25. Now I have that neat formula, so I can do 5 times 25 minus negative 20 times 10, which equals 325. So now that will go in for each of these. Now I can figure out what my x and my y are. So if I do x, didn't mean to do that, didn't want to go the first time. I want to do x. X equals my coefficient determinant on the bottom, and then this determinant on the top. M, then N, so 8, and then negative 2. B and G, so negative 20 and 25. And then if I go, same idea, 8 times 25 minus negative 20 times negative 2 divided by 325. That equals something. So if we do this out, you'll end up with 32 on the top over 65. So I found my x. I know that you are all capable of just plugging that in and figuring out what y is, but do not do that, because if you do that on the ones that I specifically say to do all of Cramer's rule for, I will take points off no matter if I'm grading it for completion, because the point of this is to learn Cramer's rule. So for this one, y is the same idea. I still have 325 on the bottom, and then in my determinant here, I will have A and M, so A goes first because it's my x, and then m goes next because that's my constant. And then f and n, so f is my x, and n is my constant, and notice they're from the same equation. So if I go with that, then I have 5 times negative 2 minus 10 times 8 over 325. And if we do that out, we get negative 18 over 65. So that means that my solution set, your answer for this one, would be 32 over 65 and negative 18 over 65. Now the next example is the one, it's in your book, it's on the next page. Not only can we do a system of equations with 2 equations, but we can also do a system of equations with 3. This is where I'm changing up the homework, and this will be written out on the calendar, so if you forget what I said, go ahead and check the calendar at the end of the day, and it'll be up there correctly. On the homework, I have given you some systems of 3 equations, and I want you to pick only one of those. I've given you 3. I want you to pick one of those that you do every single step for, that you figure out Cramer's rule for every single step along the way. The other 2, you can figure out those systems of 3 equations either by doing only 2 determinants and figuring it out from there. There's a couple that you might be able to only do 1 and figure it out from there. So you can pick one to do every single step, and then the other 2 you can do them however you want, plugging them in. However, for the second order or the systems of 2 equations, I do want you to do those ones all the way, but I will write that out so you can see exactly what I just said. On the next page in your textbook, this example is in that on that page. I think it's this exact example. There's also Cramer's rule for a system of 3 equations. It gets really messy. They're all third order determinants, so they all take a really long time. So on this one, we're just going to set it up and talk about what it means rather than talking about how to do the third order, because I'm having you guys do that on your homework. So before we get into that, one of the things I forgot to discuss was why determinants matter. So if you notice on the notes yesterday, one of the answers was 0. And so if my coefficient determinant on this one, if this coefficient determinant is 0, then I would be dividing by 0 here, and then that means I would have no solution or infinitely many. So determinants help us determine whether or not a system of equations has a solution. So on this one, we'll just go ahead and set everything up correctly, and I'm going to put my variables for everything. So this is A, B, the book uses C. I'm going to use D, because some of us are getting confused in class with talking about the different C's. So I'm going to say A, B, D, and then M. This next one is F, G, H, and then N. And then this last one is J, K. Notice how I write my L, and then P. If I want to set up my coefficient matrix, I just take all of my coefficients in each of these problems. So 4, 3, and 7, 5, negative 2, negative 6, and negative 6, 7, and negative 8. Then I could go through and figure out what that is, and I will just say that I get a number. So this is my invisible number that I get. Then if I wanted to set up the other ones, I would have x equals this mess. I won't rewrite it. Did not leave myself enough room again, but that's okay. M in P. So M in P is negative 14, 47, and 15. And then notice I just take all of my y coefficients, so 5, negative 2, and negative 6. All of my z coefficients, negative 6, 7, and negative 8. And then you could do that one. And then the same idea for y. So y would be instead C. Notice now I'm going to have another determinant. So now I'm going to use all of my x coefficients. I'm going to put the constants in place of my y coefficients. Oops, 47, 15, negative 6, 7, and negative 8. And then I could solve that one from there. Then my last one would be z. it'll be over my coefficient matrix, coefficient determinant. Use the values of x, or the coefficients of x, coefficients of y, and then the constants on the side, so negative 14, 47, and 15. Then if you did all of those out, which we won't if you need help doing those, look in your book, because this is the exact one, but I don't want to waste your time going through this, and we talked about it yesterday, and I would rather you have practice doing it on your homework rather than doing it as quote-unquote busy work as part of these notes. So anyway, so you would just solve for each of those. You figure out your x, your y, and your z. If you are doing one where you aren't doing every single step, you still can. I'm not telling you you can't. You still can, but you could just figure out what your x and y are, plug those in for z. Maybe you just figure out what your x is. Maybe you could figure out what y and z are from there. Anything you want to figure it out. I encourage you to do that as well, but make sure you are doing one completely out in Cramer's rule. So the last part is just talking about how to set up a system of equations. So if you are using the book on page 226, this is number 38, and since you're looking at this on a screen, I'm pretty sure you can read it. So we'll just underline the important parts, and I won't read it out loud. We know that the bus averaged 65 miles per hour on the highway and 25 miles per hour in the city. Art Museum is 375 miles away. Took the class 7 hours to get there. And I want to figure out how many hours the bus was on the highway and how many hours it was driving in the city. So if I'm setting up a system of equations, this is a system of 2 equations, so I will need 2 variables. So you could either pick your own variables, so you could say, you know, whatever the first letter is of whatever you're representing, you could do that. I would suggest using x and y, since we do have so many other variables being used, x and y aren't used. So in this case, I want to know how many hours the bus is on the highway. So I'm going to say x equals highway hours. And y equals city hours. Setting up your own system of equations, remember that I said it doesn't matter the order that you set them up in because it will all work out in the end. If you want to try that out, you can, and it should work out in the end for these 2 by 2 or these second order determinants. The third order determinants are a little bit more iffy for that, but I have not given you a word problem with third order determinants, just a second order. So looking at this one, I know that it took the class 7 hours to get there, so highway hours plus city hours gets me to 7. And I know that we average 65 miles per, or 65 times the number of hours on the highway, and then we have 25 miles times the number of hours in the city, and that's 375 because it's 375 miles away. Now you have your A, your B, your M, your F, your G, your N, and you can plug all those things in and figure out what it is using Cramer's rule. This is one that you will use Cramer's rule. I do not want to see you doing second order determinants without doing Cramer's rule for these systems of equations, because they do not take that long. The third order ones, you can just do one of those like that. It's because a lot of people are taking the EOI, and I don't want to overwhelm you guys with a ton of information at once. So practice one. I gave you a lot of third order determinants on your other homework, so just do one of those. So that's basically it. If you notice, if you didn't do 17, just look at 17A and 49. Those are word problems that are similar to the triangle problem. 13 through 16 are second order, and then 18, 19, and 23, pick one to do fully. The other 2, you could figure out what 2 of them are and then plug it in. You might be able to do more. And then 47 and 48 are word problems that are second order. Like always, if you have questions, let me know. The homework is not due until Tuesday. So if you have questions on Monday, let me know. Just because it's due Tuesday doesn't mean you do it Tuesday. Make sure you are working on it, because it is kind of a lot of material, but I think it's important for you guys to know. I will also on the test give you all of these equations for Cramer's rule, so you can get all of your variables straight. just because I don't want you guys to have to memorize those on top of it being the end of the school year and having the EOI. You can also do this on your calculator if you can figure it out. Monday I might show you guys how to do it, but if you can figure it out yourself, then go ahead and do it with a calculator, and that's fine by me. I don't mind. As long as if I asked you in class, you would be able to explain the process behind it. So anyway, like always, ask me if you have questions. I'm always here in the morning, so you can come in the morning or in the afternoon, or set up another time to meet with me. But I hope you guys have a good weekend. The amount of homework shouldn't be too bad. You do once again have until Tuesday, and we're not going to work on this on Monday. We're going to do EOI prep on Monday. So talk to me if you have any questions or concerns, and I hope you guys have a wonderful weekend.